Hello everyone, it's me Hazim Syahmin from Group 4 along with 4 other members which is Sean, RIDZUAN, YASMIN and ZULFA. Now, we are assigned with one project, that open-ended project regarding piping system. We are required to design a pipe system that supply water to R&R consumption. Pretty tough, but with the cooperation from everyone, we managed to do this on time. We designed the piping system based on water tower that usually seen at the R&R area. One of the factors in choosing layout and size of pipe is high flow rate of water by the consumers for their supply, for example, washing themselves and also for cooking, like for the cafeteria or food courts. The material of pipe that we chose to connect between these two places is the iron cast type, and the second type of pipe we use is PVC or polyvinyl chloride. The pump is selected when it comes to the optimal power need to transport water to the water tank tower. Moreover, the water tank tower height is decided by considering NPSH to prevent the cavitation from occur. These are some of the objectives. First, to apply knowledge that have been learned in this course for a better understanding in calculation and practical. Second, to produce thoughtful engineering student with creative and innovative thinker. Third, to design implementation of the piping system at R&R area, which must be technically sound, reliable, and economical. Then, to encourage the engineering student to get involved in the learning process and to reflect on the basic conceptions and practices included mechanics. And last but not least, to reduce the heat losses as much as possible and ensure the water supply is sufficient to be used by all of the consumers.
I'm going to explain about the project flow. First and foremost, we discuss about the project plan through rebates to reach an agreement. We decided to design a parallel pipeline system connecting the sub-water tank to distribute it to all small consumer or facilities such as food store, toilet and surau from the main water tank, which is the water tower. We roughly sketched the plan to have a better and clearer picture of the pipeline flow so that the total length of pipeline and the type of material used can be figured out. The water tower must be placed at high state. For instance, the water tower has to build on a hill in order to make the water flows to the sub-water tank via gravity efficiently. After comparing the common material used as pipe, we decided to use PVC and cast iron, which is 100mm and 200mm diameter of pipe respectively as the pipeline system from the water tower to the sub-water tank and for the distribution pipe to all facilities at the R&R area. This project required a lot of assumptions in calculations. From the logic assumption, we have calculated all minor and major losses of the main pipe from the water tower to the sub-water tank and also all losses during the distribution to the facilities. The height of the water tank required was determined. The height of the water tower is assumed for about 50 meters. Last but not least, we managed to assume the maximum flow rate of water in order to make sure the flow is sufficient to supply water to each facility. The flow rate at the distribution pipe can be obtained by summing up all of the possible flow rate from each facility at peak period equal to the maximum flow rate.
Hi, I'm Yasmin from Group 4. There are 4 problem statements that we could obtain for our R&R water supply project. The problem statements are: the first one is how to make sure all premises areas such as cafeteria, surau, toilet receive water supply without any problem. The second one is how to consider the volume of water and its velocity so that it will flow efficiently even though many people are using water at the same time. And the third one is how to minimize the minor losses and major losses in pipe so that there will be less energy losses. And the final one is what is the best material to use for pipe system.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So I am RIDZUAN. I'm gonna talk about the pump in this project. Why we have to use pump in this project? Why we don't rely on the gravity solely? Because this project has specific tank to store the water after the distribution. The tanks are purposely to overcome the problem when the water in the main tanks is refilled or ran out the water. So in order to flow the water to the smaller tanks, the pump is needed. In this project, we use the AZHAR flow pump to add energy to the flow after distribute water from the main tanks to the smaller tanks. Why we use the AZHAR flow pump? The advantage of an AZHAR flow pump is that it has a relatively high discharge at a relatively low head. It has single stage high specific speed impeller for high flow, low head. The flow rate change for AZHAR flow pump is 5,000 to 200,000 gallon per minute. Total head range are about 10 to 30 feet. Because of that, it can pump up to 3 times more water than other fluid at lift of less than 4 meters as compared to the more common radial flow or centrifugal pump. As you can see, these pumps are suitable for our project.
The water delivery system to R&R area is shown as the diagram. As we can see here, the water from the lake or reservoir or water source will be treated first at the water treatment plant and pumped into the water tower, which is 50 meters tall. The next diagram shows the pipeline system to deliver water for consumption at R&R. There are 3 main usages of water at R&R, which is the food court, toilet, and surau. The pipes are connected from the water tower to the water tank in each of these 3 places. The pipelines are not connected together in one system because this will affect the flow rate. For example, if the toilet is fully occupied, more water will be used in the toilet and this will reduce the flow rate at the food court and surau. This shouldn't happen because there are lots of people who will drop by the R&R, and if the water flow is very slow, it will be very inconvenient for them. Therefore, we came up with a design which will prevent this situation. We connect the pipeline separately for each water tank. This will not affect the flow rate because they are all independent to each other. So these are the materials that we decided to use. The grey rectangle is a cast iron pipe with a diameter of 200 mm and it has an equivalent roughness of 0.26 mm. The yellow square is a rectangular 90-degree elbow, fretted, and it has a minor loss coefficient of 1.5. The orange circle with a cross in it represents the impeller pump. The black rectangle is a PVC pipe with a diameter of 100 mm and it has an equivalent roughness of 0.0015 mm. The green color symbol represents a fully open global valve with a minor loss coefficient of 10. Lastly, the blue color rectangle is a water tank which is located 5 meters above ground level for food court, toilet, and surau. Before we head into the calculations, these are the assumptions that we are going to have. First, the water tanks at the food court, toilet, and surau are assumed to be on the same ground level, which is 5 meters. Next, the average water temperature is 18 degrees Celsius, hence the vapor pressure and kinematic viscosity can be obtained through the table. Furthermore, the flow rate and velocity of water of food court, toilet, and surau are the same. Besides that, the pump is assumed to have an efficiency of 80%. Last but not least, to assume the usage of water at R&R area, we have to assume that there are 4 persons per vehicle. 50 vehicles will visit the R&R every hour, which means that 200 persons will visit the R&R every hour. If the usage per person is 10 liters, then the usage for 200 people will be 2000 liters. Now for the calculation part. We have to know the MPSH required and also the power needed to drive the pump. So after we solve the equations with the assumptions made, we can conclude that the pump we use must have a maximum MPSHR of 60.12 meter to prevent cavitation. It must also need at least 351.8 watts to power it so that it can have an efficiency of 80% and the flow rate will be sufficient for the consumption at the R&R.
Our R&R water supply project, we need to consider the material and the size of the pipe system. Before further explanation, a pipe is defined as the tube made of metal, plastic, wood, concrete or fiberglass. It is important to select the best pipe material to obtain a better and efficient piping system. In this project, we all are agreed to use iron cast pipe and PVC pipe. This is because there are more advantages that we could obtain by using this type of materials. Even though it is a good material, but there are still disadvantages for these types of materials. Pipes are used to carry liquids, gases, slurries, or fine particles. A piping system is generally considered to include the complete interconnection of pipes, including inline components such as pipe fitting and flanges. Pumps, heat exchangers, valves, and tanks are also considered part of piping system. Piping systems are important in this R&R water supply project for the consumption of R&R. There are certain considerations or factors that need to be done in choosing the right material for the piping system. Therefore, the factors that need to be considered are: the first one is material being transported. The second one is temperature of liquid passing through. The third one is the pressure of the liquid handling process. The fourth one is service life of the fluid handling system. The fifth one is ease of maintenance. The sixth one is exposure to external elements. The seventh one is fitting size, and the last one is the cost of the material. As I mentioned before, the material used PVC pipe and cast iron pipe. In this project, this pipe is used to supply water for the consumption of R&R such as food court, surau, and toilet. The advantages of using PVC pipe are: it is strong and lightweight, it has low absolute roughness, it is non-toxic, so it is safe material, it has corrosion resistant, quicker installation time, long service life, lower cost, and has chemical resistant. The disadvantages of PVC pipe are: it will be melt at temperatures of only a few hundred degrees, it only available in a small number of sizes, it is more prone to cracking and contain traces of compounds that are harmful to the environment. The second material we use is cast iron pipe. This pipe is used to connect water supply from water tank to the located R&R. The advantages are: it is available in large quantities, it can be given any complex shape and size without using costly, it has 3 to 5 times more compression strength compared to steel, it has low stress concentration, it bears low cost, it has durability. The disadvantages of cast iron pipe are: it is prone to rusting, it has poor tensile strength, and it has poor impact resistance. In conclusion, by applying fluid mechanics concepts such as Bernoulli's equation, continuity equation, net positive suction head, and PSH and energy losses, we are able to determine the size and material of pipe, pump, and height of the tank. The material that we chose for our pipe are cast iron pipe and PVC pipe. Choosing the best material is important because we need to consider many factors that will affect later. The ability to withstand high pressure, corrosion resistant, high temperature resistant, and durability need to be considered. The advantages and disadvantages of material pipes also need to be considered to make sure the volume of water and its velocity so that it will flow efficiently even though many people are using water at the same time. Next, the pump that we chose is AZHAR flow pump. Pump is important to add energy and connect water supply from water tower to water tank. Therefore, in our calculation, NPSH is included. To prevent cavitation to occur, the pump selected to pump water into water tanks in food court, toilet, and surau must have NPSHR below or same 60.21 meter. We also use radial system layout to make sure quick and efficient service at R&R. Last but not least, our highest gratitude and thanks to our beloved lecturer, Dr. Ms. Hasimawati, Dr. Arif, and Dr. Shazwani, who helped us through our journey in finishing this project. Not to forget, thank you to our project teammate for completing this task together. Thank you from the bottom of our heart. We hope this project will benefit all of us.